Welcome to Macroblock this conference 2017. I'm going to be the speaker this year, and I'm trying to share the new idea of our driver product. They will be specific for the ultra fine LED display. It's a highly integrated solution. So what's the ultra fine LED defines? Which means those product is designed below pitch 1. So let's get into it. So what are the features we have this year? The first one, BGA package. Almost comparable, smaller, same size to our MBI 5353. So it fulfills the ultra fine tree trend. The second, we emphasize 3 highs. Those are integration, high grayscale, and high refresh rate, especially during the low grayscale. And the third one is a modularized layout solution. There will be new features to the engineer. Easy to check your Gerber file, and also you're not going to make a lot of mistakes. And the final part will be early failure detection. Those features we're going to talk about in detail in the future slides. Well, highly integrated solution will be look like this way. The left side is traditional driving structure of LED display. This is our new solution. MPI 5359 combine remote switches and the driver in the same package. So what's the benefit for this structure? As you can see from the left-hand side picture, that's our demo in this year. You can see from at the entrance of our conference room. Well, you can see the only compared to the traditional way here. It's almost the same size of the display, 0.9. And you can see there's a lot of free space at the back of PCB, which means you can reduce your scan line as low as possible. But for the traditional way, it's not possible because all the drivers, all components, all full at the back of PCB. Okay, let's go through the detail. This is the old way. You can see a lot of lines, no circle around, all over the back of PCB. But you can see from the right side, it's almost the same structure, but for the highly integrated solution, those routing lines is going to be more regular. Let's see the detail on the next slide. Here is the Gerber file of our demo board here. You can see through the picture. Almost every area around the driver is almost the same. So it will be easy to do the routing, and also for the engineer to share the details. And also, the routing rule is much more regular. So it's probably take less time for the customer. Time to market is going to be less. Well, we're going to introduce 3 high specifications. The first one is, because it's a highly integrated solution, so one driver IC controls a certain area of the LED. Well, you can do the calculation. It will be 16 by 32. So the total pixel maximum we can control is 512 pixels. You can see from the picture, it's a dash line. Separate each area of the control area. Well, you can see that the scan line is not sharing anymore, which means we can provide much more performance to our customer, because under this structure, also reduce the high contrast interference issue. Well, the second one is high grayscale. We're talking about the true 16-bit. We're not talking about the 14-bit anymore. It's a true 16-bit driver. So you can see from the performance, the gradient is last longer. So what will the customer feel? Let's go to the next slide. You can see from this picture, the input signal is the same, but you can see from the detail somewhere around your eyes. Well, the idea of how to observe high grayscale and between low grayscale, there will be some of the detail during the low grayscale is going to be loose. You are not going to see. So take a clear look at the picture around the eyes. Well, the third one is we are talking about the refresh rate, but we are not going to talk about the refresh rate during the free turn-on. We emphasize the refresh rate under the low grayscale. You can see from your right-hand side here. That's the effect you can see from the camera. That's what we are talking about when you have low refresh rate under low grayscale. But from the left side, there should be a performance for the high refresh rate during the low grayscale. Well, when we come to this part, we like to explain more because during the old days, failure report only when the LED is dead. But for our new technology, which is patented, we can sense the LED before failing. Because we work with some of the company like packaging house and also the chip vendor, and we figure out the way how to sense the LED before failing. And from the left-hand side of the picture, this is the picture you can see before the failing, but some of the customers still see the LEDs still turn on. The right part is LED is broken, but it's still turned on. But through your eyes, it's not easy to find out what's wrong. So you have to do the sensing and the report from the control, and you can repair before you are shipping out. So it will be good for the LED display manufacturer. And also, when an end user chooses this kind of a driver, there will be a benefit for you to do the as I mentioned before you buy the display. And also, failure report is important because the picture is final. So it's impossible for customer using your eyes to find the defect point. So once the LED is failed, you can do the sensing, and through the control, you can exactly find out where the question is and do the repairing. And this is also a new feature for our product, MBI 5359. And let's come to this part. For the previous product, Hawkeye 200, which is version 2 of Hawkeye series, we also emphasize the power saving. And we name with smart power saving because the customer don't have to do anything. You just plug your display and use it. And the driver will provide the power saving automatically by itself. But in this year, because this new product is a highly integrated solution, which means in our way, we only do the smart saving by the driver. And this year, because we integrate the power switches, we are going to save more powers to our customer. Well, we come to the final part. What are the benefits for the customer, but also for the end user? Well, for the manufacturer, because it's going to be easy to do the layout. and also you decrease your time to market. And the second, because it's a high integration solution, so we are not aiming the end product up. We aiming the product below 1 meter, which probably falls around 0.7 meter. And the third one is, the measurer can always do the burn-in. After burn-in, some of the AD is broken, but it's still functional. But the performance is low. So we can do the repair after the burn-in. Not only the failed LED, but also the failing LED. Well, to the end user, because it's a true 16-bit of a solution, so you're going to have a superior image quality. And also, because we have an early fail report, and also, if your manufacturer do the repair before shipping, you're going to get a high quality display. And the last one, smart power saving. Well, we do it better because the high integration, we switch off the switch also. So the total power saving up to 25%, even more. And I guess this is the end of the presentation. So any questions, come to our website, www.macroblock.com.tw, and thank you.